Welcome to another video on digital electronics. In this video, we'll be seeing standard representations for logic functions. So functions are represented in the form of equations, and there are two standard ways of representing those equations. The very first one is called as SOP, which is called as sum of product. And you can see an example here. So AB is a product, AC bar is a product, BC is a product, and there is sum between these products, and hence it is called as sum of products. If you see the second form of standard representation, it is called as POS, which stands for product of sum. So we have sums here. A plus B is a sum, A plus C bar is a sum, and B plus C is a sum. And between these sums, we have product. Hence, this is called as product of sum. So let us discuss the first case, SOP. How do we represent it and how to implement this basically? So we'll take the same equation, AB plus AC bar plus BC. If it has been asked to realize using basic gates, then in basic gates, the standard representation is called as AND OR representation. So we have two levels of representation. First, we will do the AND of all these, and then we'll add all of the gates. So we have A here, B here. It goes to an AND gate. Then we have A, C bar. This also goes to an AND gate. Then we have BC. This also goes to an AND gate. So this is AND. And the second step is to do an OR function. So this is function F. I get an output here F. Now this is called as level 1 of representation, and this is called as level 2 of representation. So this is level 1 and level 2. Given an SOP, always for basic functions, for basic gates, the representation remains a standard AND OR representation. If you have to represent the same equation using universal gate, then NAND gate is the one which you should represent. So for SOP, it is either AND or for universal, it is NAND gate. It is easy to represent using a NAND gate. Let's see how. I'll rewrite the equation here again. The equation was AB plus AC bar plus BC. Anytime if you want to represent using a NAND gate only, the very first thing that you're supposed to do is put a double complement or a double bar. By doing a double complement, we are not changing the meaning of the equation because complement of the complement nullifies each other. So I put a double bar and then I use a De Morgan's theorem which says break the bar and change the sign. So we always break the internal bar and not the external one. So I have AB bar, sign is changed, plus becomes multiplication, AC bar, again multiplication, and AC bar, the bar, and BC. So I have broken the internal sign, and we have one more bar which is throughout this. Now I can easily represent this equation using NAND only, which is a universal gate. Let's see how do we do that. So I have AB goes to a NAND gate, and what I get from here is AB bar. Then I have AC bar. This also goes to a NAND gate, and what I get is AC bar, the whole bar, because I have C bar already. Then I have BC through a NAND gate. I have BC bar. So I have implemented only this part of the equation till now. So AB bar I have in my hand. I have AC bar, the whole bar in my hand, and I have BC bar. When I implement one more NAND gate, what happens? You multiply all this function and a complement over it. So I have AB bar into AC bar into BC bar, and NAND does multiplication of all this and a bar. So I get the same equation. So always remember, given any SOP form, if it is an basic gate, we represent using AND OR. Otherwise, universal is NAND gate representation. So thank you so much for watching. I will see you next time. Thank you.